Greetings of the day, students. I'm Dr. Swapna Amod Patankar from Bharati Vidyapeeth, Team to the University, Dental College and Hospital, Pune, from the Department of Oral and Maxillofacial Pathology and Oral Microbiology. Today I will be introducing to you microscope and microscopy. So let's begin this mesmerizing journey from the macro world to the micro world. We will explore the fascinating transition of the visible and larger structures around us to the intricate and tiny details that will be seen only under the microscope. This journey will deepen your knowledge of understanding the complexities and of course understanding the beauty of the macroscopic as well as the microscopic realms, which will reveal the hidden wonders under the microscope. So before we embark on this journey, it's very important for you all to understand the microscope and the microscopy techniques. So let's first understand the different parts of a microscope. A microscope is an optical instrument that is used to see the small tiny structures which are invisible to the unaided eyes. So an example of microscope is in front of you. Now what is microscopy? Microscopy is the scientific method or a technique by which we will see these tiny objects by using a microscope. So let's classify microscopes. There are n number of classifications for a microscope, but let's take to the simplest one, depending upon the number of lenses. We have a simple microscope, which means just a single lens, that is a magnifying glass. Then we have a compound microscope, which consists of more than one lenses. It's actually a combination of many lenses, and that is what we are going to understand today. So I have a few examples of these different microscopes in front of me. This is a monocular compound microscope. Monocular because it has one eyepiece. This is a binocular compound microscope as it has two eyepieces. And this is an example of a trinocular compound microscope which has two eyepieces and a third eyepiece through which we can click pictures. Now let's discuss the different parts of a monocular compound microscope. To understand this microscope, we will divide its parts into suprastage parts and the substage parts. This is the stage of the microscope. As the word suggests, it is a flattened area. This will hold the glass slide with the help of these micro threads which are present. On this, you can also appreciate the vernier scales X and Y axis. These vernier scales will help us to locate the focus of interest. So it can record the markings and you can see the focus of interest later. This stage also has an aperture, as we can appreciate it here. This is the aperture. Now this aperture shape may vary, but normally it is 1 to 1.5 inches in diameter, and it takes a glass slide of 3:1 inches in diameter. Now the parts above this stage are the suprastage parts. So let's see them one by one. This is the eyepiece. As the name suggests, from here we will be able to see a magnified image of the small object that is used to see under the microscope. Now this eyepiece forms a virtual image of the object which is seen by the eye. This part is the body tube. This body tube, according to manufacturer, is of 160 millimeters. The actual length being 142 and the length of the revolving nose piece as 18 millimeters. The revolving nose piece will house n number of objectives. Now as you can see here, they are color coded. We can see here, this is the red color. So this is a scanner view. It may be 4x, X stands for magnification, or 5x depending upon the manufacturer. Then we have a low part which is shown by the yellow ring, that is 10x or 20x according to the manufacturer. Then we have the high part, which is indicated by a blue ring, which may be 40x, 45x or 60x, again depending upon the manufacturer. And lastly, we have the highest magnification, 100x, called as the oil immersion objective. So what is the purpose of this objective? The objective is responsible to form a primary image of the specimen. It is also responsible to control the quality of the image that is formed. It forms a real image of the object. Coming to the next, that is substage parts. Now in substage parts, as we can see here, this is the illumination. Now for illumination, we have an inbuilt source of light. Now this light will fall on the condenser. Now in this condenser, if we appreciate it here, you can see an aperture. You can see an aperture here. This is the iris diaphragm. This iris diaphragm is responsible for controlling the amount of light that enters the microscope. This part is the condenser. Condenser is made up of many lenses and it is basically responsible to control or condense the amount of light which comes from the source and falls through this aperture on our glass slide where the specimen is there. Coming to the different other parts of the microscope, as we can see here, this is the arm of the microscope with which you can hold the microscope. At the same time, it connects the suprastage to the substage parts. This is the base of the microscope which holds the entire body of the microscope. Then we have the adjustment screws. This is the coarse adjustment. As you can see, when I turn it, the stage is moved up and down. The stage is moved up and down. The coarse adjustment is responsible to bring the object in focus. The smaller one is the fine adjustment. When the fine adjustment is done, it is responsible to bring about sharpness in the image once it is focused. Along with this, we also have screws for the stage. These screws will help to move the stage, the clips of the stage forwards and backwards and from side to side. This will also help to bring the specimen or the area of interest in focus. So along with monocular, binocular and trinocular, our department has a unique pentahead. As you can see here, 5 people can see at one go. Now why this is important? Because this helps for diagnosis and also for teaching learning purposes. With pentahead, we are able to discuss and determine and give an accurate diagnosis of the pathology that is sent to our department. This is one more addition to our variety of microscopes in the department. This is the stereo microscope. This microscope works on low magnification and it gives us a 3D visualization of the specimen. So it is very useful tool for research purposes. This was a normally used compound microscope. Along with these, with advancement, we have specialized advanced diagnostic aids that is in form of specialized microscopy techniques. Just to name some, we have electron microscopy, fluorescence microscopy, confocal microscopy, phase contrast, polarized, and the list can go on and on. Now, why do we require these advanced microscopy techniques? This is going to enable us to understand the biological processes, the materials, and scientific discoveries will be possible by using these advanced diagnostic techniques. Thus, to conclude, microscope and microscopy are a boon to our medical sciences. They are indispensable tools for research and diagnosis, and especially true in my department of oral and maxillofacial pathology and microbiology. If you master then the microscope and the microscopy, you will be able to uncover the hidden wonders, to understand the details of biological processes, and significantly will be able to contribute to the knowledge which is available, the scientific knowledge, as well as advancements in healthcare. Thank you.